Torque is something people like to talk about when they're trying to sell you a diesel car. Diesel cars tend to have a higher max torque on the spec sheet than petrol cars, so yes, it's heavy, and yes, it's slow, and yes, it sounds like a snoring pig, and yes, the acrid cloud you leave in your wake will kill little children, but look at all the torque. Hoping that the big number will fool you into thinking that the engine is somehow, not shit. When we say torque, we essentially mean force going in a circle. We all know what force means when we're pushing something in a straight line. It's a measure of how hard we're pushing. When we're turning something, we call it torque. This is why it's given in pounds, feet, or newton meters. A pound-foot is the force of 1 pound of weight on a lever 1 foot from the fulcrum. A newton meter is the force of just over 100 grams weighing down on a lever 1 meter from the fulcrum. So you burn fuel in your engine, and the expansion of burning gases drives the crankshaft round and round. The engine torque figure refers to how hard the engine is pushing each time it turns over. All other things being equal, a bigger engine delivers more torque because more fuel is being burned every time the spark plugs ignite. But the engine that delivers more torque isn't necessarily the more powerful engine. Force and power aren't the same thing. If we had an earth-moving competition between me and this JCB here, we'd find that the JCB is far, far more powerful than I am. Not because it can move a ton of earth. I can move a ton of earth too. We consider it more powerful because it can move a ton of earth all at once, and it'd take me ages. Power is a measure of how much work is done per unit time. So the power generated by an engine is a function of engine torque multiplied by how fast the engine is turning over. And petrol engines rev considerably faster than diesel engines. If you look at this Skoda Octavia VRS, it comes in 2-litre petrol and 2-litre diesel flavours. You get 190 horsepower out of the diesel and 230 out of the petrol. But that same petrol engine in a Seat Leon Cupra puts out 280 horse. These people who tune car engines reckon they can get nearly 400 out of it. And that sounds impressive until you realise that current Formula 1 cars have 1.6-litre engines putting out 600 horsepower. So how do you make a small engine act like a big engine? One way is to make it rev ridiculously fast. The Formula 1 engine revs to 15,000 RPM, which would be totally impractical in a normal car for normal people. The other way is to force extra air into the engine cylinders, so that when the fuel-air mixture ignites, it explodes with extra force. You can do this with a supercharger or a turbocharger. A supercharger is essentially a fan driven by the engine crankshaft that pushes extra air into the engine, and a turbocharger is a supercharger driven by a turbine in the exhaust pipe. There are disadvantages to charging your engine. At high RPMs, a supercharger saps some power out of the engine and makes it less efficient. Turbochargers don't do anything at low RPMs. If you have a car with a turbocharged engine, you can see this for yourself. If you go up a gear and put your foot down, you'll find that nothing happens for a couple of seconds, and then the car suddenly speeds up as the turbo gets to work. So if you're trying to escape from the police, you'll have to make sure you're in the right gear at all times. Are there situations where you want lots of torque instead of lots of power? Yes. When you're pulling something very heavy. If you tied a Boeing 747 to the back of a Formula 1 car and tried to tow it, you'd find it very hard not to destroy the clutch. That gigantic mismatch between the engine spinning away and the slow pace of the wheels would be complicated to say the least. Trains are even heavier than airliners, so they don't bother with a clutch and drive them with electricity. Even in a diesel locomotive, the engine normally isn't mechanically linked to the wheels at all. It drives a generator, which sends electric power to the wheels. Incidentally, trains are really, really efficient because they don't have big fat rubber tires. They don't make sharp turns and they don't go up hills, so they don't need a lot of grip. This allows a train to be incredibly aerodynamic, just slicing through the air like a knife. The Eurostar can hit 200 miles an hour, and it does it with only about 22 horsepower per ton. For comparison, an Aston Martin Vanquish can hit 201 miles an hour, but per ton, it needs nearly 15 times as much power to do it.